Welcome to Decoded Maths. Today I will be going over the first chapter of A-level maths, which is coordinate geometry. It's not a very difficult chapter. There are just a few new formulas that they will be testing you on, and the rest is basically the same. So, as we start off, I just want you to know these three formulas before we move on, because these three formulas will be tested on really often and are the most important. So there is this one new formula that is a little different from the rest. It's basically the angle between the two lines. It's pretty straightforward. You just use this formula. There isn't much else to it. Moving on, so there are two types of lines that they will be testing you on. One is parallel lines and perpendicular lines. You should know that parallel lines have the same gradient, and perpendicular lines, well, if m1 is 3, the m2 will be the negative reciprocal. So you're just going to flip this equation and just put a negative sign right in front of it. So then we come to equation of lines. The slope form is honestly the most important one. Why? Because the others are just a derivation of the first form, right? So personally, I find this one to be very handy. This one, I mean, it is a little hard to remember, so if you want, you can skip it, but if you do remember it, it will help you a lot. So you use this formula when you have 1 point given and the slope is given, and the 2-point form when you only have 2 points given. So rather than going through the hassle of finding the gradient and the y-intercept, just use these formulas. They are more like a shortcut. And then we have shapes. So there are a few properties that you should know: that the diagonals meet at the midpoint for these 4 shapes, and the diagonal meet at 90 degrees for these 3 shapes. So of course the property of perpendicular lines is applied over here, which, sometimes you might want to use this formula if they're asking about the gradient. There's one more thing you should know, is that sometimes they'll give you a shape and they won't give you the coordinate of one particular point. So you have to figure that out. The most easiest way to go about this is that you're just gonna take the diagonal coordinates and just make it equal to the other diagonal coordinate, which I've given right over here. Same goes for the y coordinates, so you can use that formula. And I've given you a slight solution over here of this question. The last thing you should be knowing is the area of irregular shapes. Now, there are many approaches to these type of questions. I've seen many people, what they do is that a graph is given and they just make an easier shape like a rectangle, right? Just find the area of the rectangle and subtract the extra area that is given, and then you can find this area. That does work, but sometimes you will find that a little hard to do. So this is a method that works every single time. It's the matrices method. It looks scary, but honestly, it's a lifesaver. So how do you go about this? Well, you just take any point. You can start from here or here, any point. So the point you start with, so x1, y1, x2, y2, and then you also end with the exact coordinates you started with. So over here, I started with 5 and 9. So 5, 9, 8, 9, 10, 4, 1, 1, 5, 9. And then I'm going to find the determinants, right over, like I've written right over here. So you're going to find the determinant, and then you're going to add it up and divide by 2. All right? So it's it gets you the answer pretty quickly as compared to the other questions. And there isn't much of a thought process behind it. It's just a simple formula that you can always apply to any irregular shape. Now I'll just practice a few questions from the past papers, and you're basically just done with this chapter. So the first question reads, the curve y equals to 9 minus 6 over x and the line y plus x equals to 8 intersect at 2 points. So whenever they mention the word intersect, you're supposed to basically put equal these two equations that they're given you. That's how you find the exact coordinates where they intersect each other. So what I'm gonna do is I'm gonna make y the subject for both the equations because it's a little easier right now. Sometimes you can also make x the subject, but it really depends on the question. So 9 minus 6 over x equals to 8 minus x. You're going to solve this, and that will give us 0 equals to x squared plus x negative 6. You can solve this by middle term breaking or use the calculator. So I will do middle term breaking to give a visual representation of how I've solved it. So the two x coordinates that we get are negative 3 and 2. I'm going to use these exact coordinates to find the y coordinate. You can pick any of these two equations and insert the x value. I'll use the other one. I'm going to use y equals to 8 minus x. And when x equals to 2, y equals to x minus 2. 8 minus 2. That gives us 6. So our first intersection point is 2 and 6. Second point would be y equals to 8 plus 3. Y equals to 11. Second point would be negative 3 and 11. The second part tells us to find the equation of the perpendicular bisector of the line joining the 2 points. So, a visual representation would be, if this is point A and this is point B, the perpendicular bisector will cross the middle of that line. So, from here, which would be the midpoint, A to M and M to B, the distance is going to be the same. So I know that I can apply the formula of the midpoint, which is x1 plus x2 over 2, and then comma y1 plus y2 over 2. 2 plus negative 3 over 2, 6 plus 11 over 2. That gives us, that's going to be negative 0.5 and 8.5. This is the coordinate of our midpoint. And the second thing, okay, so what I can do is I can find the gradient of A and B, which is basically the coordinates of the 2 points, and then I can find the gradient. To find the gradient of the perpendicular bisector, I'm just going to apply the formula. M1 multiplied by M2 equals to negative 1. So let me show you how to do that. First, I'm going to do y2 minus y1 over x2 minus x1. That's going to give us negative 1. And our perpendicular bisector gradient would be 1. So I just flipped this value. It's going to be 1 over 1, negative 1, and multiplied by negative again. So that's going to give me 1. And now I'm just going to form an equation. So we have the gradient and the 2 points. So we could do y minus 8.5 equals to 1x minus negative 0.5. That's gonna give me x plus 9. This is the equation of the perpendicular bisector. Question number 2 reads, points A, B, and C have coordinates 2, 5, 5, negative 1, and 8, 6. Part 1, find the coordinates of the midpoint of AB. That is pretty simple. x1 plus x2 over 2, comma, y1 plus y2 over 2. Now, I'm just going to insert the values. 2 plus 5 over 2, comma, 5 plus negative 1. Divided by 2. That gives us 3.5 and 2. You can also write it as 7 over 2 and 2. Second part requires us to find the equation of the line through C perpendicular to AB, give your answer in the form given. So I'm going to draw some lines to help me figure out. So let's say this line is AB and there's a perpendicular bisector that also passes through the points of C, okay? So C is 8 and 6, B would be 5, -1, and A is 2 and 5. I would first want to find the gradient of AB. So that would be 5 minus 2. This gives us -2. The perpendicular bisector gradient would be the negative reciprocal, that would be 1/2. Now I know the C coordinates and that's exactly what I need, so I'm gonna make the equation now. So y minus 6 equals to 1/2 x minus 8. Now if you rearrange this equation, you're gonna get 0 equals to x -2y plus 4. And that's your answer. Question number 3 says the point A has coordinates -1, -5, and the point B has coordinates 7, 1. The perpendicular bisector of AB meets the x-axis at C and the y-axis at D. Calculate the length of CD. Firstly, I would want to mention that they've given us a clue over here. So the bisector of AB meets the x-axis at C, which means that coordinates would be this, and for D would be this. So we know that one of the coordinates is 0, and we just need to find the other coordinate. And if I show you a visual representation through a graph, it would look something like this. Okay, so AB is this line, and then another line, which is the perpendicular bisector, passes through the points C and D. First, you're going to find the midpoint, and then the gradient of the midpoint, make an equation, and insert these missing values. I'm going to start off by finding the midpoint. And let's find the gradient. The gradient of the perpendicular bisector would be the negative reciprocal. And now let's make the equation. Y minus 2 equals to minus 3. That gives us y equals to -4x over 3 plus 2. Now let's find the missing coordinates for C and D. Let's find C first, which is x and 0. Y would be 0, equals to -4x over 3 plus 2. That gives us x equals to 3/2. So our C coordinates are going to be 3/2 and 0. For our D coordinates, we're going to have it like -4/3, 0 plus 2, y equals to 2. So our D coordinates are 0 and 2. Now all we've got to do is to find the distance. This is the distance formula, and we know the coordinates of C and D. And we're just going to insert it into the formula. That's our answer. Question number 4 reads, the point M is the midpoint of the line joining the points 3, 7 and negative 1, 1. Find the equation of the line through M which is parallel to the line x over 3 plus y over 2 equals to 1. Okay, so let's say that point A is 3 and 7, B is negative 1, 1, and M is the midpoint of both these points. So let's quickly find the midpoint. Okay, now we need to find a gradient in order to make an equation. So we have the point, we don't have the gradient. So if you realized, you've told us that the equation that is parallel to the line M is this one. So I'm going to write this. I'm just going to manipulate the answer from this exact equation. Let me quickly simplify this. And our gradient is negative 2 over 3. Now let's just form an equation for the line passing through M. Y minus 4 equals to negative 2 over 3 x minus 1. This is the final answer. If you want to simplify it more, you can, but this also works. Anyways, that's it from my side. Let me know if you want to cover any other topics from A levels, and I'll do that.